Hello everyone, welcome to the first lecture of the Pro Lego video tutorial series. So in our last lecture, our prologue lecture, we just went over the basics of the interface of Creo elements. We went over the parts that we're using, that we'll be using for the course, and we just went over how to modify settings within Creo. So for today, we'll be making our part, first part that we'll be using. So here, click New, and then you see we have part and our subtype Solid. Solid meaning that it's a homogeneous solid, so the properties will be the same throughout. Our part is meaning that it's just a solid part that we're creating, so there's nothing moving inside of it. So for our name, we'll call this plate 1x1, and the common name we'll just leave blank. But so you can see by our name, we'll be creating a 1x1 Lego plate. So click OK. So now you see we have our datum planes from last time, our top, front, right side. We have our default coordinate system in the center, and we'll start out by creating a sketch. So we can go to Sketch. So we'll click Sketch. Automatically we'll have our sketch window appear. Select the sketch plane that we want to sketch on. So in our case, we'll do a top-down view, so we'll create the top. So click Top, and we have filled in. We have our reference, which is the front datum plane. We have our sketch direction, which we can change. Just changes the view, which way we're looking at the sketch. But from this, we can basically just click Sketch and be on our way. So we have set up our reference axes. So the dotted or the dashed orange lines indicate that those axes are used as a reference for the sketch, meaning that when we create a feature inside of the sketch, the dimensions will be with respect to those axes. So for instance, if we create a rectangle, we click Rectangle, so you see our cursor will change to show that we have that we can draw to the corner of the rectangle at that point. We click and drag. You'll see we have our rectangle that we're creating. And if we hold this in a certain way, we can see two L's appear. So below the top H and to the left of the right V. So those indicate that our rectangle is actually a square. The sides are constrained to be the same length. If we move it out of the way, we can see that goes back to normal. So let's keep it like that and click. So we've created our first feature, a rectangle. Go back to the Select tool, so click. So now we have a rectangle. We zoom in, you can see we have our dimensions as well. So when we create a feature, by default, Pro Engineer will insert dimensions. So these dimensions place the feature with respect to the reference axes, and also with respect to other parts of the feature. So you'll see we have a dimension here going from the horizontal reference axis to the top horizontal line. We have our horizontal line dimension going from the two vertical lines. So, and obviously when Pro Engineer creates dimensions, it creates them as so-called weak dimensions. So if we highlight this again, we'll see we have SD3, and we have the dimension length, and we have in parentheses weak, meaning that it's just sort of assigned by Pro Engineer. So there's some kind of default sort of scaling of the grid. So however we draw the feature will be sort of arbitrarily sized. So what we want is actually much smaller. So we can manually click and drag parts of this rectangle. So you see, if we click one of the sides, or if we highlight one of the sides and click and drag, actually change the size of the rectangle. So this is a good way to sort of shape your part before you actually define dimensions. You can zoom in again to get a closer look. So now as for our part, we're dimensioning a 1x1 Lego square, or Lego brick. So we can change these dimensions here by double-clicking. You'll see a text box appear. We'll type in the value of dimension, so say 0.8065. Click Enter. So that automatically defines our dimension here. Highlight this. You'll see SD1, our dimension, which is typed, and now it's defined as a strong dimension, meaning that we specified that, so therefore it's within the program that we've altered this. Now we want to create a square from this, so instead of having to go down to this dimension and typing the same thing, because we want this to always be a square, we can set a constraint. Now a constraint basically just constrains entities to, let's say, lines or being equal. So for instance, if we go over here and see we have vertical constraints, we click the arrow to the right of this, you'll see we have a set of constraints. So we have our equal constraints. So we click this, and click SD1, we'll click this dimension here. So now we have an equivalent dimension between the one we've set and the one that we've constrained to be equal. So E1, E1. We can also get to this is a side note, we can get to the constraints by going to Sketch and then going to Constrain. So we'll see we have the same options. The Sketch drop-down menu basically contains the same tools as what are in the side tool strip, but we'll just use this out of convenience. So now we've set those dimensions, but we want to have this square now be in the center of the origin. So we want to have the origin, or the center of the square, be the center of the origin, and we have 2 dimensions left to set. So now, instead of having to manually sort of compute what our side length divided by 2 would be, we can set a relation inside of the program to do that for us. Relation basically is a mathematical equation that's used by a pro engineer to sort of generate one dimension or one feature with respect to another feature or another dimension. So just to illustrate that, if we go to the dimension tool, so you can see on the side we have normal dimension. So click. Now, we're going to dimension this line here with respect to this line, or vertical reference. So we will click once, click the reference, and then middle mouse click. So middle mouse click, and that'll place our dimension. So you'll see that'll also be golden color, so I mean that we're specifying it. So I believe the horizontal dimension was SD1. So if we type in, so we have dimension we just created equals SD1 divided by 2. Hit enter. Now a window has appeared that's not on this window, but it's basically asking me, do I want to set that dimension as the following relation, SD1 divided by 2. So click OK, or just hit enter. So now we'll see that we have our square is now constrained to the vertical axis, in the center of the vertical axis. We can do the same thing. So we have dimension highlighted. We'll click the top line, and then click the horizontal axis, then place another dimension. Mouse button click. Then type in the same thing, SD1 divided by 2, enter, enter, and we have our part placed right in the center. Now, just to show how relations work, if we highlight this dimension, we'll see dimension name, value, we'll see it's relation driven. Now, relation driven means that it's driven by another dimension or another feature within the program or within our part, namely this dimension here. So if we do what we did before, we click on the one of these nodes and drag. So you'll see we're changing the value, we're changing the length of the side, but we're always remaining centered with respect to the origin. So just Control Z, go back to normal, and after that, we'll click the check mark to indicate that we're done creating the feature. So to see what that looks like now, hit Control D, default orientation. So we have our sketch that is now ready to be extruded into our 3D object. So from the side tool strip, we can select the extrude icon, or optionally go to Insert Extrude. So you'll see we have a new panel appear at the top, and the first thing we'll do is select our sketch. So we just highlight, you'll see anything that can be extruded will be highlighted if we mouse over it. So we have our sketch, it's highlighted, click, and you'll see we'll have our preview created. We have our, basically we can control the height of the extrusion just by sort of dragging this node here. We can control the direction by clicking the arrow in the center, and we can control more precisely what the height would be, or what the depth would be, by clicking this text box, or dimension text, double click. So the depth of the plate is 0.3226 centimeters. So we'll click enter, and you see our part's created, or our extrusion is now formed here. So optionally we can also, so by default this is set to, our closed sketches are set to be extruded as solids. We can extrude this as a surface as well, meaning that we're extruding this as just 4 datum planes instead of actually creating a whole solid inside. We can also set, so our dimension that we just input, we also set in this drop-down box, which also contains sort of a list of other, I guess, recommended sizes, which none of these are really recommended for us, but it'll save what we've input. So if we wanted to go back to a dimension that we just input that we don't remember what it is exactly, we can always see underneath of here, and it's usually saved. So we'll click solid, and we'll click the check mark indicating that we're done creating the feature. So we have our brick now. So the next thing we'll do, we'll create another sketch to create the stud on top of the brick, which the studs, of course, allow the Legos to sort of interlock and mesh so that they don't fall apart. Click sketch again. Now, so we've created from our original 3 datum planes in our sketch, we've created extra datum planes that can also be used to draw features on, or draw sketches on. So you see when we click sketch, we move over the top datum plane at the top of the brick. We can see that this is highlighted, meaning that we can sketch on it. So if we click, let's click, and then click sketch, so everything's set up and click sketch. So now, when we create our drawing, we are drawing on the top of the brick, as opposed to drawing one of the datum planes as we did before. So when we create a circle, create our peg here, or our stud. So now you can see we can auto-constrain the circle to sort of the center. As we move around, we can see the constraint icon appear around the cursor. It's constrained to the horizontal axis. Now it's constrained to both axes. Now it's constrained to the vertical axis. So we'll constrain to the origin because that's the easiest option for now. And so we'll click. You can drag the mouse to size the circle. Click again to confirm the circle, or to create the circle, and then we will click the select icon to be able to edit our dimensions. So now that the regular dimension for the circle would be 0.478 centimeters, which defines the diameter of the stud for the Lego bricks that we're working with. So from there on, we can actually, before we exit out of this, we can check just to show when you're extruding parts, if you have, let's say, sort of a strange shape that you're working with, if you having issues with extruding after you created your shape, and you might want to check whether what you're extruding is actually close or not. We can check the I-beam there's sort of the eye icon up here, which is shade closed loops, meaning that we'll shade any features or any geometries that are closed up. So for a circle, it's obviously closed up because it's, you know, a circle can't have any kind of cuts in it. So if we click the eye beam, we'll see the inside of the circle is shaded. So this is useful just again to see if what we're extruding is actually going to extrude as a solid, or if it can only be extruded as a surface. But for now, we'll just click done. Click extrude again. So let's change this to 0.178 as our height. Hit enter, and then click done. Okay, so now what we have here, I guess, looks more like a Lego. We have our stud created. We have the profile of the brick. We just need to have the inside sort of hollow to, you know, for the stud to actually sort of latch onto when we're using these. Obviously, when we create when we create assemblies, our assemblies won't be constrained by the friction as in like the real world. If we're actually creating Legos, it's more of just relations, or the you know, sort of relation between the parts that we're assembling. But just to let you know, that doesn't actually, you know, this is more of, I guess, sort of aesthetics, as opposed to actually, you know, doing anything for us. So we'll create our hollow. So click sketch. Now click the bottom. We'll click the bottom datum plane. So we'll see our sketch direction, reference setup. Click sketch. So now we want to create basically an offset from the edge here to create our hollow. If we know we know how the peg should fit, where basically we should have a rectangle that is coincident with the outer edge of the peg. So one of the things we can do is we can reuse. So we have these datum lines that are created from our previous sketch, or our previous extrusions as well. We can reuse those. So we have the use command, and we have within that the offset command. So we'll click offset. Just have a box up here just to ask us what type of offset we want to create. So a single offset basically offsets a line either, you know, left or right, or up or down by a certain amount that we specify. Now what we want is loop, which will basically, if we click the center here, you'll see the entire the blue area, or the area around the perimeter around the rectangle will turn blue, indicating that that's a feature that we can offset. We'll click that, so left click. So the direction is inward, and our offset value is 0.16425. So click the checkbox. So now we have our offset. We have our square that we wanted to create. You can see it's shaded. If we turn this way, you can see that it's basically, so it is tangent. These edges are tangent, but just to show you what that would actually look like, how that works. We can see that what we created is actually, you know, in the correct spot. So click close, and then from here we'll just click check. So we're done. Now click extrude again. So now the extrusion tool can not only be used for creating you know, solid extrusions, we can also use it to create cuts. So we have this area that we actually want to, so this area in gold, we want to actually remove this. So we'll click the arrow just to know that we're cutting inward. We'll drag this down a little bit. So now the depth of the cut that we're creating will be the same depth as the stub that we just extruded. So we'll double click, say 0.178, enter. So now we have at least the right size for our cut. So we have solid selected, and we have this option here, which is the remove material option. So we click this, you'll see another arrow's appeared. So we have our shape that we're wanting to extrude, or wanting to cut. We have the cutting direction. So cutting direction means that if we click So pointing inward means that we're removing the material inside of the cube. If we click out, then we're removing the material outside. So for now we want to remove the material inside, so we'll click to move back in, and then click OK, click check. So you'll see we'll have our hole now created, or our hollow is now created. So this part, the last thing we want to do is make the hole that is in the center of this part here. Now, the hole again is more for aesthetics. It's a product of when the Lego is injection molded, when it's created. But let's do that to make it, look nicer. So I just selected the hole feature. Now instead of actually creating circles and sort of doing an extruding cut, we can create sort of a canned feature within the program. We can create a hole. So we'll place that hole on the bottom axis. So you'll see we have the hole here. And so now by default so the pink area is where it's constrained to, meaning that it's constrained to this plane that we've created. So we can move this around anywhere, but it's remaining on the plane. Now we want this to be in line with this circle here. So now what we want to do is, first and foremost, it's setting up here to turn on datum axes. You can turn on and off datum axes. So if we click the axis, you can see that axis now that axis now appears in the center. We want to have this axis be coincident with this axis for our circle. So if we press Control and click the axis, you'll see we've now constrained this to both this plane and this axis, meaning that it's fully constrained in terms of where it's being placed. So now we can change the diameter, we can change the depth of the hole. So if we click on the diameter, change this to 0.258, hit enter. We'll change this to our depth of the hole to 0.388, hit enter. So now it clicks check mark. You see we have a hole that we just created that is in line with this peg and is also in line with or constrained to the bottom surface. So let's Control D, so we can go back to default orientation. So we basically created our 1x1 brick, which, I mean, if you know how many Legos there are in existence, it's not very, we created basically a fraction of what actually exists. But it's a start. So now that we've created all this work, we don't actually want to lose this. We go to File and Save. Now it's always important to make sure that you've saved whatever you've created, just because when you exit the program, there's no autosave feature. So if you exit and it prompts you to say, would you like to save whatever we have, there's nothing that's asking you to save. It says, do you want to exit? Because you'll lose everything if you exit now, meaning that anything that's not saved. So you have to manually remember to save whatever you made, which is kind of an inconvenience, but it's something you got to deal with. So we just make sure that this is saved. So we have our Pro Lego directory. Just creating a folder here called Lego Parts. Click OK, and then so we have our name. So the name of the part. We have the current directory. Click OK. So now our part is saved. So the next time we open Pro Engineer, we can open up this part and edit this again. So that concludes the first tutorial, first lesson. And thank you guys for watching, and I'll see you later.